please have out your notes to solving one-step equations, multiplication, and division. Today our objective is to solve one-step equations by using multiplication and division. Alright, so vocabulary words today are multiplication property of equality. So that means if you multiply both sides of an equation by the same number, your new equation will have the same solution as your original equation. Division property of equality is pretty much the same thing. If you divide both sides of the equation by the same non-zero number, the new equation will have the same solution. We have to put that non-zero in because remember, whenever we divide a number by 0, that's undefined. The beach ball is under the water and that doesn't happen in real life, so that is undefined. Okay, just like our goal yesterday with solving addition and subtraction equations was to isolate the variable, we're going to isolate the variable again today. But to use the inverse operation, we need to think about what operation we're doing. So if we're solving a multiplication equation, the inverse operation, or what operation undoes multiplication, would be division. And the same thing with division, the operation that undoes division is multiplication. As it was yesterday, you can check your answer by replacing the variable with your solution, performing that math to see if you get the number on the other side of the equal sign. Example 1, go ahead and split your workspace in half and let's do two different types of equations. The first equation we're going to do is a division equation. I'm taking k and I'm dividing it by 18 and I want to get 72 as my answer. So I'm looking for a number, k, that when it's divided by 18, we're going to get 72 as the answer. Remember, the inverse operation of division, and this fraction bar right here, the vinculum, is a fancy schmancy way to write division. So when I read this, k over 18, I can also read it as k divided by 18. To undo division, I'm going to use multiplication, and I'm going to multiply on both sides of the equal sign, just like yesterday, where I have my wall, and I'm going to show my inverse operation, which is multiplying by 18 on both sides. 18 divided by 18 is 1, and 1k is just k. So those battle out, and what's left on this side is a k. Then 72 times 18. Well, that's going to require a little bit of math, more than just mental math. So I'm going to go ahead and do that math off to the side so I don't mess up my pretty little work there in the middle. Okay, 2 times 8 is 16. Carry my 1. 7 times 8 is 56 plus 1 is 57. Cross that out. Add my 0. And then 72 times 1 is just 72. Add those together. And I get 1,296 as my answer. Okay, so my solution was k equals 1,296. We can check that solution by plugging k back in. In examples 2 and 3, we're going to apply the same concept of solving multiplication and division problems by using the inverse operation, but this time, instead of whole numbers, we're going to have decimals and fractions. So remember your concepts. If you're solving a multiplication equation, you're going to need to divide both sides by the number. If you are solving a division equation, you need to multiply both sides by the number. Let's do 60k equals 54. Now I want you to do this one on your own, so go ahead and pause the video, solve it, check it, and then hit play to make sure that you got it right. Alright, I know that I need to isolate k, so I need to think about what operation I'm doing to k. When a number and a variable are hugging, that means multiplication. So to undo that, I need to divide both sides of my equation by 60. 60 over 60 simplifies to 1. so k survives on the left side. And then 54 divided by 60. Well, that's going to be a decimal. It's a less than 1 because 54/60 is a fraction less than 1. Let's go ahead and divide out. 60 does not go into 54, so I need to write a 0 and add the decimal and a 0 so I can drop it, and keep going. Okay, so 54 minus 0 is 54. And then I got my 0 that I can drop it. And then 60 and 540. Because both numbers end in 0, I'm just going to go ahead and look at 6 and 54. I know that 6 goes into 54 9 whole times. So 9 times 60 is 540. Okay, so my answer would be 9/10. But I can always check it by plugging in 9/10 for k. And since I'm plugging in, I'm going to put the number inside parentheses, which means 60 times 9/10. So let's do our multiplication. You don't have to line up the decimals, just line up the numbers. 0 times 9 is 0. 6 times 9 is 54. And then if I cross that out and do the zeros, I'm just going to have another row of zeros, so I can stop there. Since this number has one decimal place, I know that my answer, my product, is going to have one decimal place. So 60 times 9/10 is 54. Since this check matches what I started with, I know that k equals 9/10 is the right solution. So remember, all this math down here was just to check your answer. How'd you do? Example 3. We're going to deal with some fractions here. So go ahead and split your workspace in half. We're going to solve the same equation two different ways. 3/4 times y equals 3/8. Okay, my goal is to isolate the y, so I have to undo the multiplication of 3/4. I undo multiplication by dividing both sides by the coefficient, which in this case is 3/4. So I'm going to divide 3/8 by 3/4. I need to remember that dividing fractions, 3/8 divided by 3/4. Well, my rule for division of fractions is to multiply by the reciprocal, or drop, switch, and flip. So I drop my first fraction, switch to multiplication, and then change 3/4, so I'd flip it to the reciprocal. So that would be 4/3. So 3/8 times 4/3. I can cross simplify to make my life a little bit easier. And I know that 3/8 times 4/3 is 1/2. Okay, so that was all the math that was needed to be on the right-hand side to find out what 3/8 divided by 3/4. So that would have been 1/2. I know 3/4 divided by 3/4, a number divided by itself is always 1, even if it's a fraction. So y survives on this side. So I get an answer of y equals 1/2. I can go ahead and check by plugging in 1/2 in for y, 3/4 times 1/2. I don't have to find a common denominator with fraction multiplication. I can just multiply across. 3 times 1 is 3. 4 times 2 is 8. I got an answer of 3/8 as my check, and since that matches what I began with, I know that y equals 1/2 is the solution. Alright, now, you did all of that work. Yes, you can divide both sides by 3/4, but really what we need to be thinking about is y, 3/4 y equaling 3/8. What we really did, and if you look back at my little thinking bubble over here, 3/4 y, dividing both sides, is really, honestly, multiplying both sides by the reciprocal of 3/4. So let's try that. Let's try multiplying both sides by 4/3. Alright, when I do that, I've got a 4 and a 4 and a 3 and a 3. Those all cross simplify to 1. So y is left on the left-hand side. And then I have a 3 and a 3. Those cross simplify to 1. And then a 4 goes into 8 twice. So that would be 1/2. I still get y equals 1/2 as my solution. Although what I did, instead of dividing, I multiplied by the reciprocal, which is really the same thing. Both ways get you the same answer. You can do both ways, but just remember that dividing by a fraction is really multiplying by the reciprocal. So you can go ahead and just shortcut yourself and multiply both sides by the reciprocal of 3/4.